Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in our lecture. In last lectures we completed our unit 1 and 2. Now we start with unit number 3. In this unit we studying about different classes of drugs like anesthetics, antispasmodic drugs, antihistamine drugs, anticoagulant drugs and anti-cancer drugs. Last one, anti-cancer, is divided into this unit, and also some parts of drugs is in unit number 4. And in unit 4 we derive it as a neoplastic drugs. So we studying only 4 class: anesthetic drugs, antispasmodic drugs, antihistamine drugs and anticoagulant drugs in this unit, and remaining one, anti-cancer, is in unit number 4. Now we start our unit number 3. First of all, the class of drugs is anesthetics drugs. Anesthetic drugs. In this class, we first of all introduce this class and some drugs, namely diethyl ether, benzocaine, procaine, xylocaine and stovain. We synthesize these drugs and their medicinal application. So, first of all, we start with introduction of anesthetic drugs. The term anesthetic is derived from the Greek word anesthesia, which means insensibility, and hence anesthetics may be defined as those drugs which produce insensibility to the vital function of all type of cells, especially those of the nervous system. The effect produced by an anesthetic is reversible, which means that the affected organ return to the normal state as soon as the concentration of the anesthetic is decreased. This is the very important point. Very important point. Anesthetic is reversible. It produces effect reversible. So, after the completion of any surgery, the patient will come in normal state. So it is very important. Effect produced by anesthetic is reversible. Thus, an anesthetic produces temporary insensibility to pain or feeling in the whole body or a particular organ which has to undergo the surgical operation. Under anesthesia, the patient has no agony during the operation, and the surgeon works carefully, patiently and effectively. The advent of anesthetics has revolutionized the surgery. In summary, an anesthetic should provide a, a safe and pleasant anesthesia for the patient. B. Sufficient relaxation so that surgery can be readily achieved. And number C. Prompt recovery of the patient to preoperative physiological norms. Even though we do not have the ideal anesthetic agents, with the combination of anesthetic and ancillary drugs now available, it does appear that in skill hand this objective can be achieved. An ideal anesthetics agent should have the following characteristic. Some of the point list out here which in ideal anesthetics. So the characteristic of ideal anesthetics are: number 1, it should be inert, essentially non-metabolized. Number 2, it should be potent and non-flammable. Number 3, it should produce rapid and smooth induction. Number 4, it should be non-irritating to mucous membrane. It is very important. Non-irritating to mucous membranes. Number 5, it should produce not only anesthesia but also analgesia and muscle relaxations. This is also very important point. Number 6, it should not produce severe hypertensions. Number 7, it should be non-toxic to brain, liver, heart and kidney tissues. It is also a very important point. Anesthetic should not toxic to brain, liver, heart and kidney. Number 8, it should not produce nausea or vomiting. It is also very important. Number 9, it should be compatible with ancillary drugs used in the anesthesia. Number 10, it should be economical and usable with existing anesthetic equipments. It is also very important. We have some equipments in which we use anesthetics, so it should be economical and usable with existing anesthetic equipments. And number 11, it should be stable to soda lime, light and heat. So these are 11 points which is in ideal anesthetics. Now, in general way, the action of volatile anesthetics may be divided into following 4 stages. These are the main 4 stages of anesthetics. Number 1, pre-anesthesia, the induction stage. Number 2, delirium or dream stage. Number 3, surgical anesthesia, the operative stage. And number 4, stage of medullary paralysis. These are the 4 steps for the action of anesthetics. Now, classification of anesthetics. As anesthetics may produce unconsciousness all over the body or in a particular organ, they may be classified into 2 groups on the basis of their applications. Number A, general or central anesthetics, and number B, local anesthetics. So this is the main 2 type of anesthetics, general and local. Now we discuss this one by one. First of all, general or central anesthetics. This depresses the central nervous system. Central or general is depress the central nervous system to such an extent that all sensitivity to pain or feeling is lost. That is, they produce unconsciousness all over the body. Classification of general anesthetics. This type is also subdivided into following two types. General anesthetics have been further subdivided into volatile or gaseous. Number 1. Volatile or gaseous anesthetics and non-volatile or fixed anesthetics. So, subdivided classes of general anesthetics are volatile or gaseous and non-volatile or fixed anesthetics. The former are administered by inhalation, while the latter by injection or alimentary canal. Example of volatile anesthetics: nitrous oxide, ether, ethylene, divinyl ether, methyl N-propyl ether, cyclopropane, chloroform, fluorethan, trilene, and Viadril, etc. are example of volatile general anesthetics. Now, example of non-volatile general anesthetics. Among them, the most important are evertine chloralose, pentothal sodium. Pentothal sodium. It is also known as thiopental sodium. So, these are the non-volatile general anesthetics. Now, we studied about local anesthetic. This is the second main type of anesthetics. Local anesthetics. These do not affect the whole body but make only a part of body insensitive to pain or feeling. Any substance applied topically or by localized injection or infiltration to dull or block pain sensation may be regarded as a local anesthetic. This is the very important point. This, when applied directly to peripheral nervous tissues, block nervous conduction and abolish all sensation in the parts supplied by the nerves. It tends to block both the generation and the conduction of the nervous impulse. The requisites of local anesthetics are follow. Here some points are stated which is the requisites of the local anesthetics. Number 1, it should not be irritant. Number 2, it should not be painful. Number 3, it should produce anesthesia without causing the damage of nervous cell. It is very important point. Without causing the damage of nervous cells. Number 4, its toxicity should be low. The duration of anesthetic effect should be sufficient for carrying out the operation. Number 6, it should be stable. It is very important for point of storage. It should be stable. Number 7, it should be sterilized without difficulties. Now, classification of local anesthetics. Local anesthetics may be subclassified into following two groups: natural local anesthetics and synthetic local anesthetics. Natural local anesthetics, as for example cocaine. Cocaine is the well-known example of natural local anesthetics, and synthetics, which may be discussed under the following categories. So subclassification of synthetic local anesthetics are: number A, piperidine or tropane derivatives. As for example, alpha eucaine, beta eucaine, euphthalmine, piperocaine, etc. Piperidine or tropane derivatives. Number B, meta and para aminobenzoic acid derivatives. Orthocaine, benzocaine, butacene, procaine, etc. are the example of meta and para aminobenzoic acid derivative. Number C, stovane and alipine. Stovane, alipine, etc. are example of this class. Number D, amide and quinolone derivatives. Xylocaine, nupercaine, etc. are example of these amide and quinolone derivatives. Number E, isoquinoline derivatives. Dimeth isoquinine is well-known example of this class. And last, miscellaneous compounds. Phenacaine, benzyl alcohol, salicylic, etc. are example of miscellaneous compounds. In this class, the drugs which have not particular group or compound is listed in miscellaneous compounds. So these are the subclassification of synthetic local anesthetics. In this group, according to our syllabus, we studied some drugs as anesthetics. As for example, diethyl ether, benzocaine, procaine, xylocaine and stovane we studying in this class. According to our syllabus, in this lecture we studying only two drugs, that is diethyl ether and benzocaine, and remaining are synthesized in next lecture. So first of all we start with synthesis of diethyl ether. Diethyl ether is synthesized from ethanol. 2 moles of ethanol is treated in presence of concentrated sulfuric acid, so the water molecules is removed. 2 moles of ethanol gives diethyl ether. This process is also known as dehydration process. In presence, we also know sulfuric acid. Concentrated sulfuric acid is well-known dehydrating agent. So, in presence, ethanol is converted into diethyl ether. Now, application or advantages of ether. Ether is a safe anaesthetics. Its principal site action is the central nervous system. It is inexpensive and when stored properly, it is comparatively stable. Some of the disadvantages of the ether. Ether boils at a low temperature. Boiling point of ether is, it is noted that it is only 32 degrees Celsius. So its boiling point is very low and is difficult to administer in tropical temperatures. In summer, there is a room temperature is 40 to 42 degrees Celsius. So it is its disadvantages. Number 2, its vapor are flammable and somewhat irritating to mucous membrane. And last, number 3, the blood solubility of ether is high and induction period is slow and often stormy. These are the advantages and disadvantages of ether. Now, last compound for this lecture, synthesis of benzocaine. Benzocaine is synthesized from para-nitrotoluene. So, this is the structure of para-nitrotoluene. This para-nitrotoluene is treated with Na2Cr2O7 sodium dichromate in the presence of sulfuric acid. So we see here as oxidation process. Our CH3 group, this is the CH3 group, this is the CH3 group is converted into COOH in presence of sodium dichromate. We also call it as a oxidation process. Now, this para-nitrobenzoic acid is treated with acid metal reduction in presence of tin and hydrochloric acid. Para-nitrobenzoic acid is converted into para-aminobenzoic acid. Here NO2 group is converted into NH2. So this is the acid metal reduction. Now this para-aminobenzoic acid is treated with ethanol in presence of hydrochloric acid. And finally we get benzocaine. For this route we synthesize benzocaine as a anesthetic drugs. Now medicinal application of benzocaine. It occurs as a white, odorless, crystalline powder form, stable in air. These are the properties of benzocaine. It is soluble in alcohol. Alcohol and water proportion is 1:5. Ether 1:4. Chloroform 1:2. Fixed oil 1:40. And in glycerin, propylene, glycol or mineral acids. Some of acids is also known as mineral acids which are obtained from minerals. It is known as mineral acids. Our well-known acid, hydrochloric acid, sulfuric acid, nitric acid, etc. are known as mineral acids. So benzocaine is soluble in this. It is insoluble in water and alkaline solutions. However, it solves with paraphenol sulfonic acid is soluble in water, and hence it is the salt of benzocaine which is used for the treatment of hypodermic infections under the name subcutane. This is the important name, subcutane. Next point, benzocaine itself is used for local anesthetic action in powders, up to 20% in ointments, up to 20% in suppositories, and for various types of surface pain and itching. And last point, generally it is used orally to prevent nausea and vomiting with compounds such as aminophylline. So this is the properties and medicinal application of benzocaine. Thank you.